In example 7.4, we are given a function g. It says define g, and we can see that g has a domain of all real numbers with an equation of g of x equals negative 4x plus 7. And it says find the difference quotient of g. And we're also supposed to simplify. So since we're wanting to do a difference quotient, and the difference quotient is a very specific type of average rate of change, I'm not going to call it AROC, I'm going to call it DQ to represent the difference quotient. And the formula for the difference quotient needs to be adapted for my function name. So it's going to be g of a plus h minus g of a all divided by h. So what I like to do is work on the different terms of this expression separately and then take the results from those computations and then bring them into my difference quotient calculation. So I'll show you what I mean by that. So in the numerator, you have two terms, g of a plus h and g of a. So those are the things that I want to do calculations for separately, starting with g of a. G of a is going to be negative 4 times a plus 7, which is just going to be called negative 4a plus 7. So we're done with g of a. Next, we'll look at g of a plus h. So this will be negative 4 times a plus h plus 7. I'll distribute the negative 4 to get negative 4a minus 4h plus 7. So that's my on the side computation. Now let's bring the results of these computations into my difference quotient expression, and that'll be negative 4a minus 4h plus 7 minus negative 4a plus 7, all divided by h. So I'll highlight here where those computations come in. So g of a plus h is everything that I have here in parentheses, and then g of a is everything that I have in this set of parentheses, and they are separated by the difference, the subtraction there. So speaking of the subtraction or the difference, we should recognize that there's some cancellation that can occur because of that difference. Negative 4a minus a negative 4a cancels out. 7 minus 7 also is going to cancel out, leaving us with negative 4h all divided by h. And now I can do cancellation because of the quotient. H divided by h is going to cancel, leaving us with the result of just negative 4. And that is what we call the difference quotient of g given by g of x is negative 4x plus 7. Now before I end this video, I do want to make an interesting observation here. G is not just any function, it is a linear function. So when you do your difference quotient calculation on a linear function, notice that the answer we have ends up matching the slope of your linear function. And that is not a coincidence. The slope of a linear function is always negative 4, no matter where you are on the graph. And the difference quotient is what generalizes the average rate of change calculation for that line.